Hi everyone, this is Professor D, and I think this is either my second or third attempt at recording 9.3, so fingers crossed that it all works correctly today. So Section 9.3 is about confidence intervals for population proportion, and it's actually in some ways easier than Section 9.1 and 9.2 because we're just focusing on the proportion here. So we're going to obtain a point estimate for the population proportion, and we're going to talk about constructing and interpreting confidence intervals for the population proportion, and finally determine the sample size necessary for estimating a population proportion within a specified margin of error. And we did objective 3 in Section 9.1 using for the Z. All right, so how do we obtain a point estimate for the population proportion? The point estimate is simply X over N. So X is the number of individuals in the sample with that specified characteristic you're looking for, and N is the total sample size. Okay, so this example, in July of 2008, a university poll asked 1,783 voters nationwide whether they favored or opposed the death penalty for persons convicted of murder. 1,123 were in favor. We need to obtain a point estimate for the proportion of registered voters who are in favor of the death penalty. Well, our X is 1123. That's the number of people with a kind of a specified trait, which is being in favor of the death penalty, and 1,783 were the total amount of people polled. So to obtain our point estimate, we simply take 1123 over 1783. So that is what we're going to use for our point estimate of our population proportion. So how do we construct and interpret a confidence interval for population proportion? Okay, a couple of things here. We need to assume or know the sampling distribution of p hat is approximately normal, with that mean equal to the p that we calculated previously, and the standard deviation is the square root of p, so p hat times 1 minus p over n. Okay, so this one I'm going to draw on here. Give you all a second to be with me, catch up with me. So when we're doing this, this is a little p hat. So in the previous example, our p hat was 0.63. Okay, and so we need to know that this is true. So we would do 1183 times 0.63 times 1 minus 0.63. And as long as that is greater than or equal to 10, we know that we have something that we can actually test. Let's pull up our calculator. And it's there's no way to make this look bigger. Okay, 1183, I think it was it times 0.63, or is it 0.67? Oh, here it is, sorry, 0.63. Enter, times, and we can actually, times, parentheses, 1 minus 0.63. It doesn't like what I did here. Well, 74.29, let's try that again. 745.29 times 1 minus 0.63 close my parentheses. And that's way bigger than 10, so we're good. The standard, we also require that each trial be independent. So if you're sampling people, really they are independent because the second person's response should not be based at all on the first person's. So how do we calculate our confidence interval? All right, so our lower bound is p hat minus z of alpha over 2 times the square root of p hat times 1 minus p hat over n, and the upper bound is p hat plus that same thing. Okay. This looks a lot, confidence intervals all have the basic formula. You take the point estimate of either the mean or the proportion, and you add or subtract that margin of error. Okay. We checked this case to be true, and we also should know that our n is less than 5% of the population. That's great. N has to be less than or equal to 5% of the population, which is true in this case. So we want to obtain a 90% confidence interval for this particular problem. We say here's where they check their numbers. Okay, the sample size is definitely less than 5% of the population. Our level of confidence is 90%, which means our alpha equals 0.1, and our z of alpha over 2 is 0.65, and it just has review. The area in the tails is 0.05, 0.05, and this area is 0.9. Okay, and then we just plug and chug. However, I am fine. Let me find it. With you guys going directly to StatCrunch. All right. So we go to Stat, Proportion Statistics, one sample with summary. All right. Number of successes. I have to check that real quick. Number of successes was what again? 1123. And the number of trials, I think it was 1783, but I'm going to just check it again. Yep, that's right. We're doing a 90% confidence level. Leave it as standard. All right, our lower limit was 0.611, upper limit was 0.65. I do remember that they rounded a little bit different. Yes, 0.61 and 0.65, so we agree. Okay, so our solution is we can say with a 90% level of confidence that the proportion of registered voters who are in favor of the death penalty for those convicted of murder is between 0.61 and 0.65. All right, let's look at a couple of examples. Practice 5. Okay, lower bound, something I wanted to do first. I think this one was, but it wouldn't load. Okay, real simple. Construct a confidence interval of the population proportion at the given level of confidence. X is 160, N is 200, and we have 99% level of confidence. So we go right to StatCrunch. Stat, make this too small, sorry. Stat, proportion, one sample. Again, proportion, one sample with summary. From our problem, the number of successes is 160 and the N is 200. We want a confidence level at 99%. Make sure to verify our data one more time. And we simply hit compute. And there it is. Calculated for us. We've got the lower limit and the upper limit. Point in the few decimal places at once. 3 decimal places, so 0.727 and 0.873. All right, we got it. Now let's look at something a little bit different. Determine the point estimate of the population proportion in the margin of error for the following confidence interval and the number of individuals in the sample with the specified characteristic X for the sample size provided. Okay, well, this we got to go back and use our buddy algebra. I'm going to check to make sure I'm still recording. It says I am. Keep my fingers crossed. All right. So the lower bound, I don't know what I just did there, is 0.59. I love that I keep getting this message. The lower bound is 0.591. And our upper is 0.859. And our N, which we'll use at the end of the problem, is 1,000. Now, if I know my lower and upper, I can find my point estimate because that's going to lie right in the middle. So I really want to find what's halfway between 0.591 and 0.859. So I'm going to add those two together and divide by 2. This is an excellent time to work along with me. 0.859, enter, divide by 2. All right, so we've got 0.2538. And how many decimals? They want us to go to 1,000. So let's see. 0.25, I'm going to go with 0.254. That's not right. That's not the right answer because it should be halfway in between the two of them. So something's wrong. 0.591. I'm looking for a number halfway in between. 0.591 plus 0.859. I'm going to divide that by 2. 0.725. That makes a lot more sense. So 0.725 is our p-hat. And we can check this because if I take 0.725 and I subtract 0.591, and I take 0.859 and I subtract 0.725, we're just trying to find the difference and make sure those differences are the same. So 0.725 minus 0.591 0.134. And if I take the 859 and I subtract the 0.725, and I did something wrong, 0.859 minus 0.725, there's that 0.134. So the margin of error is actually going to be equal to 0.134, because if I took the point estimate, which is 725, and I subtract 1.134, I get 591. And if I take 0.725 and I add 0.134, I get 0.859. So the estimate of the population proportion is 0.725. The margin of error, well, we already know that from the work we did, 0.134. And then how many people are in the sample with the specified characteristics? Well, we have 1,000 people in the sample that was given to us up here. So, you know, some of you are like, oh, that's easy. You just multiply the 1.34 times 1,000. But if you think about it, remember, our 0.134 is equal to our x value over 1,000, because that's our n value. So in order to get x by itself, I need to multiply the entire equation through by 1,000. So I'm going to get 0.134 times 1,000 equals 1,000 x over 1,000. And then these cross out. I'm left with an x over here. And then multiply, and of course this is 1,000. 0.134 times 1,000, which means I have to move 3 decimal places. 1, 2, 3. So I'm going to get 134. What did I do wrong here? Oh. Oops. What did I do wrong, guys? I used the margin of error instead of the... See, we all make mistakes. So it's going to be x. And it might help if I didn't put the decimal place in. Let's try that one more time. Third time is the charm. Okay, let's look at problem 6. Okay, this is all about interpretation. A poll of 1,027 adults in a certain country found that 55% identified themselves as the followers of some religion. The margin of error was 5 percentage points with a 99% level of confidence. Which of the following represents a reasonable interpretation of the survey results? Well, let's look at that question. So 55% would be the point estimate. And that margin of error is 5%. So we would say 5 percentage points, or 0.05 below, which would give us 50. And then we take that 55% and add 0.05, which is 60. So our confidence interval is we can say with a 99% level of confidence, the true proportion of people who identify themselves as the followers of some religion is between 50 and 60%. And there we go. And I'm pretty sure my 3-year-old just ran through here and snuck donuts into the family room. Okay. I think the last one I want to do, we will come back to actually in the next section. All right. Determine the sample size necessary for estimating a population proportion with a specified margin of error. This formula is n equals p hat times 1 minus p hat over z of alpha over 2 divided by e squared. Okay? All they've done is taken that, remember our margin of error is equal to z of alpha over 2 times the square root of p hat times 1 minus p hat, there's a 1 in there, all over n. Okay, all they have done is manipulated this formula to solve for n. Okay. And there's a problem, because the formula uses p hat, which depends on n, which is the quantity we are trying to determine, because remember, p hat is equal to x over n. Okay, so how do you work around this issue? Sometimes they'll say p hat is based on a pilot study or an earlier study, or when they don't, you just use p hat equals 0.5, which would give you the largest possible value for n for a given confidence level. And that's what they're graphically showing you here. Okay. So here's the formula for sample size required to obtain a 1 minus alpha times 100% confidence interval for P with margin of error. Now when they say where P hat is a prior estimate of P, if a prior estimate of P is unavailable, you would use 0.25. So let's work through this example. A sociologist wanted to determine the percentage of residents of America that only speak English at home. What sample size should be obtained if she wishes her estimate to be within 3 percentage points with a 90% confidence, assuming she uses a 2000 estimate obtained from the Census Bureau of 82.4. So our error was in the problem is 3 percentage points or 0.03. Our z of alpha over 2 is going to be z of 0.05, which is 1.645. Our p hat is 0.824, and then we plug in chug. Now, anytime you get a decimal, you always round up to the next highest number. So we round that up to 437. Now, with a little bit of playing, I found a way to let StatCrunch help us with this problem. It's a little wacky, so you have to pay attention here. One sample, and we're going to do power / sample size. Okay? Confidence interval width. And we're going to do a, remember this one was a 90% level of confidence. Right, our target proportion was 0.824 because that was given in the problem. Our error is 0.03, and then we compute. Oh, they got 437. I have found when I've done this, I typically, okay. And it was working last time, so there must be something I'm putting in. So I don't know why it's not working now because I have been playing with this. And I was getting it to work. The required parameter for confidence level 0.9, 0.824 for p hat. The width, I remember now. Okay, you actually, for the width, you have to put in, you know, the standard error is 0.03, but the width of the confidence interval, if you think about it, you're doing plus or minus 0.03. So the actual width of the confidence interval is 0.06. You have to take that number and multiply it by 2. And it gives you 436, but you always need to add 1 to whatever this calculator gives you, because it seems to round down and we need to round up. So there's 436, but we really need 437. Okay, let's look at the example I had. Chapter 10. A researcher wishes to estimate the proportion of adults who have high-speed internet access. What sample size should be obtained if she wishes the estimate to be within 0.02, so plus or minus 0.02, with 95% confidence if she uses a previous estimate of 0.34. So we get a stat crunch, stat, proportion, one sample, power sample size. Make sure you clicked on confidence interval width. And let's, again, a confidence level is 95%. It's already in there. All right, I'm not sure what happened. It looks like I got kicked out. So I'm going to walk you through this problem. You guys didn't lose me for too long. This is like the recording that never ends. Okay. So researchers want to estimate the proportion of adults who have high-speed internet access. What sample size would be attained if we want to? She wishes the estimate to be within 2 percentage points with 95% level of confidence. So we go to StatCrunch, stat, proportion statistics, one sample, and power sample size. Okay. Let's try to get these here so you can see them better. Okay. So here, we're doing confidence interval. It's going to be 95%. Make sure you click on confidence intervals. 95%. We're going to use a prior estimate of 0.34. And we want the width of our confidence interval to be within 2 percentage points. So the width of the confidence interval is actually 0.04. Compute. So we got 2156, but like I said, this seems to truncate down. So if you add 1 to it, you get the right answer. If you take a quiz or a test, or test 3, and you're off by 1 point and you use the calculator, just shoot me a note and I'll give you credit for that. If she doesn't use any prior estimates, then we're going to use 0.5. Let's find our StatCrunch. So again, target proportion, we're going to use 0.5. The width still is 0.04. And we're going to compute, and we're going to get 2401, so I'm going to use 2402. And there you go. All right, fingers crossed that this fully recorded. That's everything you need for Section 9.3, and good luck. Bye.